Hello children, so in this video I will be discussing about law of conservation of energy. So there are different laws related with energy. Out of that, this is one of the laws. So according to the law of conservation of energy, the statement is that energy can neither be created nor be destroyed, but can be converted from one form to the other, keeping the energy of the whole system conserved. So suppose you have a system. So the entire energy of that system, suppose universe is a system, the whole energy of the universe will remain constant. So what you will be finding is that only energy is changing its form from one form to the other, but neither you can create new energy nor you can entirely destroy energy. So how do we prove that? So we will prove it in case of a freely falling body. Okay, so proof for the above law in case of a freely falling body. So we consider a body. There is a body. Let's say the mass of the body is m and it is falling from a height h. So at three different positions, we will be calculating its total energy. Now when we say total energy, since it will be in motion, it will have two forms of energy. One is potential and kinetic. So we'll add up both. So total energy will be a sum of the potential and kinetic energy. So at three different positions, A, B and C. So at position A, when it is about to fall, its velocity will be 0. Okay. And at position B, let's say at position B, the body has traveled through a distance x and it is at a height h minus x from the ground, because the total height is h. So at position B, to reach position B, the body has traveled distance x, and when it has traveled distance x, the remaining is the height of the body from the ground. And at position C, the ball or the body hasn't touched the ground. It is very, very near to the ground. So at this particular position, we can consider the height of the body to be almost equal to 0. Height of the body from the ground to be almost equal to 0, because it hasn't touched the ground but it is very near to the ground. And at all the three positions A, B and C, the body is under the influence of acceleration due to gravity g. Okay, so all these things we need to describe. Okay, so consider a body of mass m kept at a height h from the ground. So at three different positions, whatever I have said, that you have to state in a written form. So at position A, the body is at a height h from the ground. Okay, and the initial velocity of the body will be 0. At position B, the body has traveled a distance x from A and it is at a height, how much height? H minus x from the ground. And at position C, the body has traveled a distance h. So to reach this position C, the body will travel the entire height. So it has traveled a distance h, and its height from the ground is almost 0. So h is almost equal to 0. So this I have stated here. So in all the three positions, as I told you, the body is experiencing a free fall and it is accelerating at the rate of g. So the acceleration due to gravity here is g, small g. Now what we will do at three different positions, we will try to calculate the total energy of the body at three different positions A, B and C. So next let us have a look. Okay, I hope the things are clear. Okay, fine. So at position A, what we can state, potential energy is mgh, because the body is at a height h. So the whole potential energy will be mass into acceleration due to gravity into h. Kinetic energy will be what? Half mv square. So velocity of the body at the beginning of the fall was 0. So we have considered that velocity to be 0. So what we are getting here, that we have taken v is 0, velocity as 0. So 0 multiplied with anything becomes 0. So kinetic energy at the beginning of the fall is 0. So total energy, TE means total energy, is equal to potential energy plus kinetic energy. So mgh plus 0. So total energy is mgh. At position B, now coming to position B, potential energy. Now potential energy is due to height of a body from the ground. So if we look at the diagram here, the At position B, the body is at how much height from the ground? H minus x. So the potential energy is mg within bracket h minus x. This is the height. So if you break the bracket, it becomes mgh minus mgx. Now let us have a look at the kinetic energy. So kinetic energy is half mv square. Okay. So this v will try to replace, v square will try to replace it from the third equation of motion. So from the third equation of motion, v square is equal to u square plus twice gh. So v square equal to u square means initial, because when the body, it fell from position A, at position A the velocity of the body, the initial velocity was 0. So the initial velocity is taken to be 0. So v square is equal to twice gx. So why x? Because to get this velocity, let's again go back to the diagram. To get the velocity v here, so at this here we are considering the velocity to be v. So to get this velocity v, it has traveled how much distance? Distance x. So what we are doing here, we have taken the distance as x, and while traveling the distance x, it has acquired a velocity v. So the equation becomes v square is equal to twice gx. So instead of v square, we can write twice gx. So 2 and 2 cancels out, and we are left with kinetic energy is equal to mgx. So total energy is what? Potential energy plus kinetic energy. So potential energy was mgh minus mgx, and kinetic energy is mgx. So mgx cancels out, plus and minus. So we are left with mgh. So total energy is mgh. At position C, so this is the position where the height of the body from the ground was almost 0. So potential energy is mgh. Potential energy, you know the definition, energy due to position. So what is the position? Its position is that its height from the ground is almost 0. So h, we take it as 0. So potential energy becomes almost 0. Kinetic energy is half mv square. So we'll again replace v square from third equation of motion. So v square is equal to u square plus twice gh. So u square, we know it, when it fell from A, from top, its initial velocity was 0. So initial velocity is taken to be 0. So v square is equal to twice gh. So that we have written here, we have replaced it here. So instead of v square, we have written twice gh. So 2 and 2 cancels out. So we are left with mgh. So kinetic energy is mgh. So what is total energy? Potential plus kinetic energy. So 0 plus mgh. So total energy is mgh. Hence, so what we are finding, that at all the three positions or locations A, B and C, total energy of the body is remaining same. Here also mgh, at position B also mgh, at position A also mgh. So this proves the law of conservation of energy, that during any kind of transformation of energy, the total energy of the system will remain the same. Only thing is that the form will change. Why the form is changing? You see here. Here the entire energy was in the form of potential, but as you reached very near to the ground, the entire energy got converted into kinetic energy. Okay, because potential energy becomes almost 0. So it is a transformation only which takes place, but the overall energy remains the same. So this is the proof for law of conservation of energy. So I hope you have understood the proof. Thank you so much.